Alright, good morning everyone. Today what we're going to do is we're going to work on word problems. I'm going to just go over the types of problems you'll see in IXL, okay? And today's IXL is going to be J.1 and J.10 and S.13. And these are both working on word problems. One is just solving them, solving simple word problems, getting used to the verbiage, and the next one is actually writing equations and getting used to that. Okay, so the first question here we see, it says Jeff takes 2 pages of notes during each hour of class. After attending 23 hours of class, how many total pages of notes will Jeffrey have in his notebook? Okay, so our first idea is just to be able to translate numbers to words and the situation, what's going on. So I'm just going to use my little highlight here just because I can. And we said he takes 2 pages of notes during each hour of class. Okay, so we see if he goes to 1 hour of class, he's going to have 2 pages of notes. If he goes to 2 hours of class, he's going to have 4 pages of notes. If he goes to 3 hours of class, he'll have 6 pages of notes. So after attending 23 hours of class, how many total pages of notes will Jeffrey have? So we're going to do this a couple of different ways. One, we're going to say, hey, if I just say 2 hours per class, so after 1 class, it's 2 hours. After 2 classes, we end up with 4. After 3 classes, no, sorry, other way around. After 3 classes, 3 hours, he'll end up with 6 pages of notes. And we could do this for 23 hours. And this will take us forever. But probably you guys are thinking the same thing already. We have multiplication for this. So instead, let's come up with an equation. If it's 2 pages per class, and let's use h for hours, that will give us our total number of pages. And I'll use that letter P. Now these variables could be x and y. You could have said 2x plus y. Oh, so now, oh my gosh, what am I doing? Equals to y. And we just have to label the variables. H is hours, and P is pages. Or we could have done x is hours, and y is pages. Now, a big deal here is the variables don't really matter. It's just to help you. And you can use x and y, you can use h and p, you can use t if you want, and t for time. The idea is that we use the labels to represent what we're going to plug in or what we want to find out. Again, variables, so what we want to plug in, that's changing. We use the word variable because this number is constantly changing. But the 2 here is a constant. We're always going to get 2 pages for every hour. So if we use this equation here, we can say, hey, for 2 pages per hour, and what if we had 23 hours? We have a total of 46 pages. And the idea is we're reading these word problems, just getting back into the mode of reading word problems. Now, why are word problems important? We always find them super hard and they don't relate to me. And it's because word problems are life problems. Like in the real world, your boss is going to tell you something in words. They'll never give you this equation. Right? Unless you're an accountant and you're the boss and you're giving your workers equations to fill out. Nobody gives you equations. You have to come up with these equations yourself. You translate the English into numbers where we can then use mathematical properties to calculate. And we'll see that in this step, where if I write this as an equation, I just have to plug in h, which is 23, and then we can get the number of pages total. Now again, this is just a very basic starting problem. Now what if I had 50 hours of notes? We would take the same formula, 2h equals to p, and h would be this time 50. And that'll give me 100, and we would have 100 pages. What if h was 4? What if I'm like the worst student in the world? 2 and 4 would give me 8 pages. And this is so much better than us going down the list. 2 and 4 is 8. 2 and 5 is 10. And just counting downward till we hit 23 hours. Okay? The ideas of us writing this as an algebraic equation then allows us to plug it in and solve for it. Okay, hopefully I've convinced you slightly, at least, that this would be a good idea. Alright, so let's go ahead and try another one. That we said it's going to be 46 pages. I'm going to go ahead and type in 46 here. 46. Alright, terrific. And we're going to do a bunch of these problems today, just so we can get used to it. And you can refer back to the video later. Okay, so a person can pay $13 for a membership to an art museum, and then go to the museum for $1 per visit. Sounds like a deal for me. For a member of the art museum, what is the total cost of 29 visits? So there's a couple of things that we want to catch here. First is that you have to pay $13 first, no matter what. No matter how many visits we go, we have to first pay $13 for the membership. And that gives us, a discount. And then we can then pay $1 per visit. So what's the total cost of 29 visits? Let's go ahead and write our equation here. Maybe you guys probably have worked on stuff like this before. So you realize that I always have to pay $13 first. Then we're going to add $1 per visit. I'm going to write $1 here per visit. I'm going to use the letter V for visit is equal to our total cost. And I'll use the letter T here. Again, you could have labeled this 13. Let me put that there. 13 plus 1 dot x equals to y, right? As long as you know what your variables stand for. In this case, V is my visits. Oops. And T is the total money, total cost. Of course, again, we could have done this one visit at a time because at $13 plus one visit, that's for my first visit. We can do $13 plus my second visit, plus two visits. $13 plus three visits. And we can go all the way down till we hit 29 visits. But again, this variable idea, us being able to plug it in, 13 plus 1 times 29. This is 13 plus 1 times 29 is 29, adding up to $42. And that's the total. Right, that's the total. T for total. What if this on the side was $3 per visit? What if it was $13 for membership and $3 per visit? The equation doesn't change that much. We still have to pay $13 for our first visit, and then we add $3 per additional visit. Will lead us to our total. And if I went ahead and did 29 visits, I would just stick V as 29. Okay. So the idea of us using algebraic equations is not to make life harder for us. It's actually to make life easier for us. Because we'll see some problems here. We're going to actually solve these equations that we write out. So let's go ahead and plug that in. We said it's going to be $42. 42. Submit. Keep it up. All right. So our next problem. A receptionist named Celine spends 3 minutes routing each incoming phone call. In all, how many phone calls does Celine have to route to spend a total of 24 minutes on the phone? 24 minutes on the phone. So some of you guys are probably screaming the answer already. Like, it's not that hard to figure out. But let's go ahead and write an equation for us. We know we spend 3 minutes per phone call, and we spend a total of 24 minutes total. And the question is here, how many phone calls? Okay, how many phone calls? So, but that's, go ahead and first write our algebraic equation. We said we spend 3 minutes per routing a phone call. I'll use the letter C for calls. So C is for calls. And we're going to say our total for the number of total minutes. And it takes us, we'll say T here. So if I had 3 calls, just on the side, three calls, it took me a total of 9 minutes working. What if I had 10 calls? 3 times 10 is 30. It took me 30 minutes working. 3 times, let's see, if I only had one call that day, that's kind of sad job, I would have only spent 3 minutes working. So we can experiment with our equation to make sure it does make sense. Now to solve this, they told us that we had 24 minutes working, right? So 3C is equal to 24. And then now we can solve it algebraically. Now we're back to our square one, day one problems for algebra using opposite operations. So if I want to solve for C, the number of calls I made, C is equal to 8. So they made 8 what? C stands for calls, so 8 calls. Okay, so let's read it one more time to make sure we got this. A receptionist named Celine spent 33 minutes, okay, 3 minutes, all right, 3 minutes, routing each incoming phone call. So for every call, it takes her 3 minutes. And then she had a total of 24 minutes here. All right, so it took her 8 calls. That makes sense. All right, let's see if this worked out. 8 calls. Brilliant. All right, let's do one more of these types of questions, and then we'll try to jump to a harder level of difficulty. Hopefully you're seeing that these aren't that difficult. But please take this time as I'm showing you, I'm writing the algebraic equation first, and then I'm plugging the values. I'm not just guessing the answer or trying to do mental math here. I'm writing it down so I can practice. Bridget has already written 6 pages, and she expects to write 1 page for every additional hour spent writing. How many hours will Bridget have to spend writing this week in order to write a total of 44 pages? Okay, so she wrote 6 pages already, and she writes 1 page per hour, but the goal is to write 44 pages. Let's first write our easy equation. She's written 6 pages already. She expected to write 1 page per every hour that she works. And that gives us our total number of pages. Again, you can use x and y if you want. 6 plus 1x equals to y. Where in this case, the top h is equal to the hours, and t is equal to total pages. Okay, so we said she needs a goal of 44 pages. So do we plug in 44 here in hours or 44 in total pages? Well, obviously, it's in the total pages, right? Our question is, how many hours does she work? So we're looking for this guy. So let's go ahead and plug it in. 6 equals to 1h. Oops, not 6 equals to, I'm sorry. 6 plus 1h is equal to 44. Now we're going to use our algebra to solve for it. I'm solving for h, so we want to get rid of the 6 first. So we're going to minus 6 to both sides. 1h is just h, and 44 minus 6 is, no, 44 minus 6 is 38. So we need 38 hours. Okay, because well, if she wrote 6 already, and then we work 8 more hours at 1 page per hour, we do end up with 44 pages. All right, 44 pages it is. Oops, 38, I'm sorry. 38 hours to get 44 pages. My mistake. I'm going to jump up and do one of the harder questions. This is very similar to our last one, actually. Similar problem, but let's do it anyways. The number just got bigger. Okay, Walter runs 3 miles during each track practice. How many track practices does it take for Walter to run 264 miles? How many track practices does it take him to run 264 miles? So it takes Walter 3 miles for every track practice. So we'll use the word P for practice. And then we're going to get a total number. Total here. And you can just use the letter T if you want. How many track practices does it take him to run 264 miles? So he's run 264 miles. How many practices would it take? We're trying to solve for P here. You can probably tell it's going to be opposite multiply is divide by 3. Let's go ahead and divide 3 to both sides. P is equal to, now you can do long division. I have a fast way of doing division. I try to do division as I see it. 3 goes into 2. Doesn't work, but does 3 go into 26? Yes, it goes into 8 times. Take a look, it goes into 8 times, right? 3 times 8 is 24. Remainder 2. I'm just going to write the 2 on top. And 3 goes into 24 times 8 times. So this took him 88 practices. Let me show you guys my long division trick. I think I showed it to you before. If I say 3 again divided by 264. Go ahead and try dividing it. You're going to divide 3 by 2. It's too small. We move on to the bigger number. This is just like long division. In long division, whoops, I drew it upside down. In long division, we write 3 and 264. 3 goes into 2, nope, so 3 goes into 26. The closest we can get is 8. Then remember we multiply, and then we subtract. Remainder 2, bring down the 4. 3 goes into 24, 8 times. 24, 0. That's a lot of writing. I would like to, if you guys don't have a fast way of dividing right now, please take a look at my version of dividing. We're going to divide it in this fraction form. 3 goes into 26, 8 times, right? Isn't 3 times 8, 24? So we're really close to 26. Between 26 and 24, what's the difference? We have a remainder of 2. Okay? Which is that's the number we got here. We're going to look at 24 now. 3 goes into 24, 8 times. I'm going to give you another number. 1, 2, 3, 6, 9 divided by 3. Okay? I'm going to have us divide this whole number in literally less than 5 seconds. Okay, less than 5 seconds. It looks like a huge number. But let's try it. Does 3 go into 1? Nope. Use the bigger number. 3 goes into 12. How many times? 4. No remainder. So we don't bring anything over. Next number. 3 goes into 3. 1 time. No remainder. 3 goes into 6. How many times? 2. No remainder. 3 goes into 3. Oh, 3 goes into 9. 3 times. We are done with long division. Okay. I'm going to do this backwards. 9, 6, 3, 1, 2. Okay. Divided by 3. 3 goes into 9. How many times? It goes into it, right? So we don't have to go to our next step. So that's just 3. 3 goes into 6. 2 times. No remainder. 3 goes into 3. 1 time. 3 goes into 1. It doesn't. So we have to bring in the next number. 3 goes into 12. 4 times. Oh wait, whoops, we need to include a 0 there. 0 and then 4. Oops, I miscopied one. I lost the number, right? I erased it too much. And 0 and then 4. I forgot the 0. Okay, that's it. We said our answer was going to be 88 practices. Let's go ahead and do that. Submit. All right. Okay, let's work on our next section here today was S.13. Let me get there right now. Okay, so I'm going to go through these questions along right with you, so you guys can know what you're expecting. Okay, first question. So first question is going to be, Zachary has already taken 2 pictures at home. He expects to take 2 pictures every day of vacation. Write an equation that shows the relationship between the days of vacation D and the total number of pictures taken P. So they gave us which variables to use. They told us the days of vacation will be used for D and the pictures taken will be P. And so Zachary takes 2 pictures at home already, and then he takes another 2 pictures every day of vacation. So let's go ahead and start off. So imagine this was you. You already took 2 pictures, right? We're done with 2. And then for every day of vacation, you're going to take 2 more pictures. And this will give us our total number of pictures taken. So let's take a look here. We use D for the days of vacation, and P as the total number of pictures. So once you write an equation, just double check if it makes sense. If I was on 1 day of vacation, 2 plus 2 times 1, right? Because only 1 day of vacation. How many pictures did you take? 2 plus 2 is 4. You took 4 pictures. That does make total sense. And so how are you going to write this into Schoology? You're going to write it as we see it. 2 plus 2D equals to P. So in Schoology, let's go ahead and write that. 2 plus my plus symbol, 2d equals p. And I'm going to tell you right now, if I hit this, it will be wrong. I didn't read all the directions, and this is what I did in that last class. Now, if you look what I wrote here, I wrote 2 plus 2p, and that equals to p, right? But look at how they want it. I want you guys to look here. It says write your answer as an equation with p first, okay? Did I write my equation with p first? Did I write my equation with p first? Answer is, no, I didn't. I did not write my answer with p first. Oh my goodness. I delete all that. The Chinese are taking over. So they want me to write p first, and if I don't write p first, they're going to for sure mark that wrong. P is equal to 2 plus 2d. All right, so here's a warning that they asked us to write the equal sign first, the total first, so that's p is equal to 2 plus 2d. Let's submit. Now that's correct. Okay, let's do this next problem. Darren has already written 4 pages. He also expects to write 2 pages for every additional hour spent writing. This sounds very similar to what we did on our last problems. Write an equation that shows the relationship between the hours spent writing h and the total pages written p. Okay, so a couple things that we want to make sure we know. He has written already 4 pages, and then for every hour he writes 2 more pages. The variables we want to use are h and p. Okay, so he already wrote 4 pages, so that's a given. We're going to say 4 plus. And then he expects to write 2 pages per every hour, so 2 times h. And this is equal to, I'm going to write p in the front, to the number of total pages in the front. You can double check. If he wrote for 1 hour, that means he wrote 2 pages. And that would be 6 pages. Yeah, that would make sense. He had 4. He wrote for 1 hour. He has 2 more. So p equals to 4 plus 2h. So let's go ahead and plug this in and see if it agrees with us. 4 plus 2h. Oops, sorry. We have to write p first, right? P equals to 4 plus 2h. Okay. All right, brilliant. Okay, let's go ahead and jump to a harder version of this problem. Okay, this one looks a little tougher, so let's go ahead and take it on. So this is the type of problem that's going to say, hey, here's the total. How many does it take to get there? So let's take a look at what they said. Noah has already cycled 85 kilometers for this year. He plans to cycle 3 kilometers per each work trip. Okay, so per each work trip. How many trips will Noah have to make to cycle a total of 346 kilometers? Okay, write and solve the equation to find the answer. Write and solve it. So let's first write the equation. We know he already wrote how many kilometers for this year? He already wrote 85 kilometers for the year. And then he plans to cycle 3 kilometers per every work trip. Or I'll use that as W, for every work trip. And this is going to give him his total number of miles written, right? This is our generic equation. They gave us some more information. They told us, hey, what happens if he rode 346 kilometers during his total year? So how many work trips would he need to solve? So we would have to solve for this now. All right, solving for W like we did before. Let's go ahead and minus 85 to both sides. We end up with 3W is equal to, okay, that's a 1. 6 minus 5 is 1. I'm going to borrow 1 thing, 14. 14 minus 8 is 6. And then we're left with a 2, right? That's a 2 now. 261. Then we're going to divide both sides by 3. W is equal to 26 divided by 3 is 8. So we have 24, remainder 2. And 3 goes into 21 7 times. Let me do that again so you guys can see it. It might have been a little too fast. 261 divided by 3. 3 goes into 2. Nope. 3 goes into 26 though. 8 times. 3 times 8 is 24, right? 3 times 8 is 24. We still have a remainder of 2 between 24 and 26. And then 3 goes into 21 7 times. Faster than breaking out a calculator. Faster than photomath. Okay, 87 times. Oops. Oops. Wonderful. Okay, let's do one more question that's a little harder than this. Alright, this one seems a lot more wordy. Let's go ahead and deal with it. You guys are only gonna go up to 70 though. Okay, you guys only have to go up to 70, but let's go ahead and do a harder problem. When completing an online shopping transaction, a typical shopper takes about 11 seconds to select each product and another 19 seconds to complete the checkout process. How long does it take to complete a transaction with 32 products? Write and solve an equation to find the answer. Okay, so this is a little market research going on here. And websites do calculate this, like Amazon. How long does it take you between you clicking on the website till you clicking purchase? And then how long will it take you to get through that purchase process at the end, right? The transaction process. So it says it takes us 11 seconds to select a product. And then it takes us 19 to check out. So are we going to check out multiple times or just check out once? Are we going to buy multiple products or just buy one? And in this case, it looks like we're going to buy multiple products, right? But we only have to check out once. Once you have all those things in your cart, great. Now the thing is, online shopping is only a thing since like 2000. So if you talk to people before this, people are like, what's online shopping? This is not relevant to them. So we have 11 seconds per product. I'm going to use the little p. Plus 19 seconds for checkout. Gives me a total of time I need. How long does it take to complete the transaction process? Okay, so T is my total time, and P is products. Now be careful here. We have the temptation of just plugging in 32 to T, but 32 isn't T. That's not my total time. 32 is the number of products we want, and they want us to find that total time. So this is actually 11 times 32 plus 19 seconds for checkout. That's pretty fast checkout actually. How long does it take to complete a transaction with 32 products? Yep. So we're going to multiply 11 times 32. That's going to be 32, which is 352. 352 plus 19 is 371. That's the number of seconds it took her to, or took our shopper to buy 32 products. That's pretty fast though, because 371 minutes is about 6 minutes. That's really fast. Okay. All right. So that's kind of it. This is our practice for your word problems. You guys are going to be working on IXL today on these types of problems, pretty much the same style that I went through, okay? If you need help, you can come back and watch the video or email me directly.